Hi, welcome to Python Polygon. Today we're going to start with the next topic, that is pipes and cisterns. So basically, a cistern is basically a tank, first of all. Okay. So in the previous lecture, we covered something called rates and work. Okay. This topic is very similar to rates and work, where we will be using the rate a lot. Okay. So it might be rate of inflow, it might be rate of outflow. Okay, I'll tell you what that means. So, in the beginning, there are some basic formulae. If you want, you can refer this notebook once I upload it on the Google Drive. It's there in the description, by the way, so you guys can check it out. The whole folder is there, so you can find any notebook on the Google Drive. Okay, so we'll start directly with the question. They say two outlet pipes A and B are connected to a full tank. Pipe A alone can empty the tank in 10 minutes and pipe B alone can empty the tank in 30 minutes. If both are open together, how much time will it take to empty the tank completely? Okay, so first what we do, uh, A takes 10 minutes to empty the tank. Okay, so per minute A empties 1/10 of the tank, correct? Per minute. Okay, this is nothing but the rate of A. Okay, rate of A is 1 by 10 per minute. Okay, similarly, B takes 30 minutes. So rate of B becomes 1 by 30 per minute. Okay. After this, uh, now if they are open together, then the new rate would be rate of A plus rate of B. So that will give you 1 by 10 plus 1 by 30. And common denominator 30, you get 4 by 30, which is 2 by 15. So it is 2 by 15 per minute. Okay. Now we can simply use cross multiplication. Okay, so in 2 by 15, see, we can now write it as in 1 minute 2 by 15th of the tank is filled. Okay, then how long does it take to fill the whole tank? Okay, so this is one and this is how long, so this is minutes and this is tank, right? So you get in 1 minute 2 by 15th of the tank can be filled using A and B together. Okay, because you have rate of A plus rate of B. If you guys haven't watched the rate and work video, please go watch it. It's the second video in the playlist. So that's when you'll understand all this. Okay, so total rate will be rate of A plus rate of B because they're working together. Okay, it will be 1 by 10 plus 1 by 30, 4 by 30, which is 2 by 15. So here we do cross multiplication. You get uh, you get it as 1 by 2 by 15, which is 7.5 minutes. Okay, so 7.5 minutes is nothing but 7 minutes and 30 seconds. Fine, this was easy. Next question. Two pipes X and Y are attached to a swimming pool and they can fill the swimming pool in 20 and 30 minutes respectively, working alone. Okay, so immediately we'll think about rate of X is 1 by 20 and rate of Y is 1 by 30. Okay, at this point we should assume all this in the beginning only because uh, we've done quite a lot of questions on rate and some difficult questions also in the previous lecture. Okay, so this they do working alone. Okay, both are open together, but due to malfunctioning of the motor of pipe X, it had to be shut down after 2 minutes. Okay, and then Y continued to fill the swimming pool. So we have to think about this in two parts. Okay, in first 2 minutes, X and Y are working together. Okay, so we'll find the rate of that. Rate will be rate of X plus rate of Y because they're working together. So that will be 1 by 20 plus 1 by 30, which is common denominator 60. You get it as 5, so this is 1 by 12. Okay, so 1 by 12th of the tank is filled every minute that X and Y work together. So in 2 minutes, okay, it's pretty obvious that 2 by 12 of the tank will be filled, that is 1 by 6 of the tank will be filled. Okay, so how much is remaining? 5 by 6 of the tank is still remaining to be filled. Okay, and then Y continues the job and finishes it. Okay, so we have to find rate of Y, which is 1 by 30. Okay, so what this means, how long will Y take to fill the remaining of the tank? Okay, so we know that in 1 minute 1 by 30 of the tank is filled by Y. So 5 by 6 of the tank will be filled in how many minutes? Okay, simple cross multiplication. Here we know it's 2 minutes. Okay, then we'll check the next part. In the next part, y is working alone and it fills the whole tank. Okay. So then we do cross multiplication. You get it as 5 by 6 by 1 by 30, which is 25 minutes. Okay, because this goes up and it becomes into 30. Cancels 5 times, cancels 1 time, and then you get 25 minutes. Okay, so y takes 25 minutes to complete the whole thing, and x and y together work for 2 minutes, plus y takes 25 minutes. So a total of 27 minutes is required to fill the whole tank. Okay, so that's the. Okay, the next question. Three pipes A, B, and C are open to fill a cistern. Working alone, A, B, and C require 12, 15, 20 minutes respectively. After 4 minutes of working together, A gets blocked, and after another minute, B gets blocked. C continues and fills the cistern completely. What is the total time? Okay, this is similar to the previous question, but here there is another cistern, there is another pipe extra. Okay, so first of all, we start with rate of A, that is 1 by 12 of the tank per minute. Rate of B is 1 by 15, and rate of C is 1 by 20. Okay, so then 4 minutes they work together. So we have to find the total rate as rate of A plus rate of B plus rate of C, which is 1 by 12, 1 by 15, 1 by 20. I can see 60 here. So common denominator 60, 3, 4 and 5. 3 plus 4, 7, 7 plus 5 is 12. So this comes as 1 by 5. Okay. So their rate is 1 by 5 of the tank per minute. Okay. And for 4 minutes they worked. So for 4 minutes they cover 4 by 5 of the tank. Okay. So then A gets blocked. So how much is left is 1 by 5 of the tank is left. Okay, then for a minute only A and B and C work together, so that time the rate 2 will be rate of B plus rate of C, which is 1 by 15 plus 1 by 20, that is again it's by 60 only, and this will be 4s and 3s, 7 by 60. So this is the rate for B and C. So if they work for a minute, they fill 7 by 60th of the tank. So up till now, like until now, 4 by 5 plus 7 by 60 of the tank is filled, which is nothing but 48 plus 7 by 60. 55 by 60 is filled. That is nothing but 11 by 12. Okay. How much is left is 1 by 12th of the tank is left. Okay. Now this only C has to complete, right? So what we do is we have to find out. See, rate of C is what? It's given to us as 1 by 20, right? So 1 by 20 of the tank is filled in 1 minute. So how many minutes does it take to fill 11 by 12 of the tank? Sorry, 1 by 12 of the tank. 11 by 12 is filled. So we need to fill 1 by 12 of the tank. We cross multiply. We get it as 1 by 12 by 1 by 20. That is 20 by 12, which is 5 by 3. Okay. 5 by 3 minutes it takes. 5 by 3 minutes it takes. Okay, that is nothing but 1 minute and 40 seconds. Okay, so it takes 1 minute and 40 seconds here. Okay, we have to add up all the times now. It takes 1 minute for R2 because they said so, and it takes 4 minutes here. So 4 plus 1 minute and 40 seconds. Okay, that is nothing but 6 minutes and 40 seconds. That's the answer. Next question. Three pipes A, B, and C are connected to a tank. Working alone, they require 10 hours, 12 hours, and 20 hours and 30 hours. After some time, A is closed, and after another 2 hours, B is closed. C works for another 14 hours so that the tank gets filled completely. Find out the time when pipe A was closed. Okay, so let's assume they worked after some time, right? We have to find out this sometime. Basically, that's what it means. Okay, so let's assume that some time was x. Okay, so if that some time was x, uh, the rate in which they worked, all of them worked together, was RA plus RB plus RC. Okay, from the question, RA is nothing but 1 by 10, RB is nothing but 1 by 20, and RC is nothing but 1 by 30. Okay, so the rate for the first x hours will be 1 by 10 plus 1 by 20 plus 1 by 30, that is 6 plus 3 plus 2 by 60, 11 by 60 of the tank per hour. Okay, so for x hours, in x hours, okay, x into 11 by 60 of the tank is filled. Okay, so if x into 11 by 60 of the tank is filled, now A is closed. Okay, after x hours, and another 2 hours later B is closed. Okay, so for 2 hours B and C are working together, so the rate will be RB plus RC. Okay, that is nothing but 1 by 20 plus 1 by 30, which is 5 by 60. Okay, this happens for 2 hours, so that is nothing but 10 by 60, that is 1 by 6. Okay, 1/6 of the tank is filled additionally. Okay, in the next 2 hours. Okay, in the last part they say C works for another 14 hours so that the tank gets filled completely. Okay, so the last 14 hours RC works alone, that is nothing but 1 by 30 into 14 hours is what part of the tank they fill. Okay, RC fills. Okay, this is nothing but 14 by 30, which is 7 by 15. Okay, so what they're saying is this part of the tank plus this part of the tank plus this part of the tank should equate to 1 because the whole tank is filled. Okay, so we get the equation 11x by 6, 60 plus 1 by 6 plus 7 by 15 equal to 1. Common denominator is 60, so this becomes 60, this becomes 28. We take 60 to that side. I'll write it on the top. So I get 11x plus 38 equal to 60, which implies that 11x equal to 22, x equal to 2. So in 2 hours A was closed, after 2 hours B was closed, and then for 14 hours C worked. That is how it happened. So just if you are referring. Alright, so this was that question. Next question. Working alone, pipes A and B require 9 hours and 6.2 hours more respectively to fill a pool than they were working together. Okay, for those of you who have watched the second lecture, this question is very similar to that one question we solved in that lecture. Okay, it's very easy. Find the total time taken if both of them were working together. Okay, so let's assume A and B together take x hours to fill the tank. Okay, x hours to fill the tank. That means, see, if A and B take x hours to fill the tank, in 1 hour, how much do they fill? That is nothing but rate of A and B, right? That is nothing but 1 by x, because if they take x hours, if you multiply this by x, you get 1. That is filling the tank. Okay, so rate of A and B working together is 1 by x. Okay, we agree with that. Now the next part is, see, they told that the time that A takes is, I'll just write it. So time that A takes is equal to time that A and B both take plus 9. Okay, and time that B takes is time that A and B both take plus 6.25. Okay, now we have to substitute. See, using the same logic, the time that A and B take is x hours, then rate of A and B is 1 by x. Okay, so using the same logic, if time is this much, then the rate of A and B will be how much? Rate of A will be 1 by this, right? So 1 by time that A and B take is x hours, we already told that, so 1 by x plus 9. Okay, similarly, time that B takes, rate of B will be 1 by x plus 6.25. Okay, now we know one more fact, that if A and B are working together, their rates add up, right? So RAB is equal to RA plus RB. Okay. Now we substitute RAB here. That is nothing but 1 by x equal to 1 by x plus 9 plus 1 by x plus 6.25. Okay. We solve this equation, we get the value of x, we mark the answer. Okay. That's as simple as that. Now what we can do is take common denominator. You get x plus 9. I'm going to take these two common denominator and send it to the left side. So I'm going to get x plus 9 into x plus 6.25 is equal to 2x plus 9 plus 6.25, that is 15.25 into x. Okay, this is what you're going to get. Here you get x square plus 9, that is again 15.25x plus 9 into 6.25 is equal to 2x square plus 15.25x. Okay, this and this term can cancel. 2x square and 1x square can cancel. So x square equal to 9 into 6.25. Okay, we will not simplify that because it will conveniently cancel. Again, I'm going to take it up. The last step comes as x square equal to 9 into 6.25. So x will be square root of that. Square root of 9 is 3 and square root of 6.25 is 2.5, I believe, because 25 into 25, yeah, so this comes as 7.5. So they take 7.5 hours to fill it completely, working together. Okay, next question. 3 pipes A, B and C were opened to fill a cistern. Working alone, ABC required 12, 15 and 20 minutes respectively. Another pipe D, which was a waste pipe, can empty the tank in 30 minutes working alone. Okay, what is the total time it takes for the fill the cistern if all pipes are open simultaneously? Okay, to understand this question, think about the tank like this. Okay, A, B and C are the inflow pipes, A, B and C, and D is the pipe that is going out. Okay, so anytime if two see, again it comes down to a rate question only. Okay, so if two objects are acting against each other, okay, we have to subtract their rates. Okay, it becomes RA minus RB if this is A and this is B, and if they are working together, then it becomes RA plus RB. Okay, so I can say the rate of the whole tank will be nothing but positive inflow, that is RA plus RB plus RC, okay, minus the outflow, that is nothing but RD. Okay, this is all that is we have to do. This is all we have to do. Okay, see, RA is nothing but 1 by 12. Okay, so rate will be 1 by 12 plus 1 by RB is 15, so it will be 1 by 15 plus RC is 20, so it will be 1 by 20 minus D empties the tank in 30 minutes. Okay, so it will be minus 1 by 30. Okay, this common denominator comes as 60. So this becomes 5 times, 4 times, 3 times, minus 2 times, which is 1, 5, 10, 10 by 60, which is 1 by 6 per minute. Okay, 1/6 of the tank is filled per minute, even though there is outflow as well as there are 3 pipes inflowing. Okay, so they're asking what is the total time it takes to fill the pipes. Okay, at this point we should know the answer, but if the rate is 1 by 6 of the tank in 1 minute, then how many minutes does it take to fill the whole tank? That will come as 6. Okay, 6 minutes to fill the whole tank in this given setup. Next question. 3 pipes A, B and C were open to fill a tank. Working alone, A, B and C can fill the tank in 10, 15 and 20 hours respectively. A was opened at 7, B was opened at 8 and C was opened at 9. Okay, at what time will the tank get filled completely, given that the pipe C can only work 3 hours at a stretch and then needs 1 hour of standing time? Okay, So this is a pretty simple question, but we have to analyze it completely. Okay, so we draw a timeline. Whenever there's time involved, we draw a timeline. Okay, so it starts with uh, A being opened at 7 a.m. Okay, so 7 a.m. A is opened and it works for 1 hour alone, and at 8 a.m. B was opened. So A and B. Then at 9 a.m. A, B, and C all were opened together. Okay, that's what it means. And then C can work for 3 hours at a stretch. Okay, so till 12 a.m. C can work. So A, B, and C work together. After 12 a.m., only A and B work till 1 a.m. because it needs standing time. Okay, C needs standing time, so A and B work here, and then again till the remaining of the how much ever time we need, A, B, and C can work together. Okay, because we if you analyze the options, all are near 1 a.m. in 1 p.m. So now we start with this part. Okay, at 7 a.m., 7 to 8 a.m. only our rate of A, only A is working, so rate of A will be 1 by 10. Okay, so 1/10 of the tank will be filled. So how much will be remaining? 9 by 10th of the tank will be remaining at 8 a.m. Okay, we'll just write this. At 9 a.m. the whole tank was remaining. At 8 a.m. 9 by 10th of the tank is remaining. Okay, at 8 a.m. A and B are open together. So the rate at 8 a.m. will be rate of A plus rate of B. Rate of B is 1 by 15. So this is going to be by 30 and 2 and 3, 5 by 30. That is 1/6. Okay, 1/6 of the tank will be filled in 1 hour. So if 1/6 of the tank is filled in 1 hour, then how much is left is 9 by 10 minus 1 by 6 at 9 a.m. Okay, so this becomes 3s are 27, 27 minus 5, that is 22 by 30 is remaining. 11 by 15 is still remaining at 9 a.m. Okay, I did the math and I'll substitute 11 by 15 here. Okay, next 11 by 15 of the tank is remaining now. Okay, at 9 a.m. the rate will be 1 by 10 plus 1 by 15 plus 1 by 20 because C is also added. Okay, this is nothing but 13 by 60 per hour. Okay, uh, yeah, after this they work for let's say they work for 1 hour. Okay, at 10 a.m. how much will be left? It is 11 by 15 minus 13 by 60, that is 44 minus 13. Let's say at 11 a.m. still it's going on, that is minus 13 by 60 again. See, we can see that 44 can, like, it is more than 26, so we can again add one more hour. Okay, that is till 12 a.m. how much is left we are going to calculate. Okay, so at 12 a.m. this much is left, 44 minus 39 because there's 3 13s, so that leaves you with 5 by 60 of the tank is still remaining at 12 a.m. Okay, 5 by 16 is 5 by 60 is nothing but 1 by 12. Okay, 1 by 12th of the tank is still remaining. Now C stops working. Okay, because it needs some standing time, and only A and B are working. Okay, so we have to find out how long it takes to fill the 1/12th of the tank. Okay, if A and B are working, rate of A and B is we calculated it as 1 by 6. Okay, so in 1 hour, if it does 1 by 6, how long does it take to fill 1/12th? Okay, that is nothing but 0.5 hours. That is 30 minutes. Okay, so now we go back and see till 12 how many hours passed. Okay, there is 1 hour, 2 hour, and this is a 3 hour stretch, so it is 5 hours and 5.5 hours are done. Okay, so okay, they asked timing, so at 12:30 it's all done, the tank is filled. Okay, so this is the solution. Fine, the next question. Two pipes A and B can fill a tank in 10 hours and 30 hours respectively. Due to a leak in the tank, it takes 2.5 hours more to fill the tank. How much time in hours would the leak alone empty the tank? Okay, it takes 2.5 hours more to fill the tank. What does that mean? Okay, see, we know that rate of A is nothing but 1 by 10 here. Rate of B is nothing but 1 by 30. Okay, due to a leak in the tank, it takes 2.5 hours more to fill the tank. Okay, so see, the question is not exactly clear about when it takes 2.5 hours more. So let's assume A and B are open together, and then it takes 2.5 hours more to fill the tank because of the leak. Okay, so if A and B are open together, the rate of A and B would be 1 by 10 plus 1 by 30, which is 4 by 30, 1 by 7.5. Okay, so it would take 7.5 hours to fill the tank if A and B were open together. Okay, in fact, see the number of hours. Okay, so if the number of hours that A, B, and C take minus C take, okay, if we consider it to be, it will be 10 hours, no? Because this thing is 1 by 7.5, and this takes 2.5 hours more. Okay, so now we have to find out R of A, comma B plus number of hours A and B took plus 2.5 hours is equal to the number of hours A, B, and C took. Okay, because C was, let's assume that C is the one to empty the tank. Okay, the leak. Okay, so we have to find the rate of C basically. That's what they're saying. Okay, so number of hours A and B took is nothing but 7.5 plus 2.5 is equal to number of this is nothing but 1 by rate of A, that is 1 by 7.5 A plus B plus 1 by X. We'll call the part X. Okay, the number of hours it takes to for the leak to empty the tank. So this comes as 10 this side. 10 is equal to 7.5 plus X by 7.5 into X. So it will be 7.5 X by 7.5 plus X. So this goes that side. 75 plus 10x equal to 7.5x. So we can cancel this and this. We'll get 2.5x minus 2.5x equal to 75. So x will be minus 30. Okay. So it takes 30 hours for the leak to empty the tank. Okay. It's a negative sign because the rate of the this thing leak is obviously lesser. I mean, it's negative because it's going out. Okay. So that's the answer. Next question. Two pipes A and B work alternatively with a third pipe C to fill a swimming pool. Okay. Working alone, A, B, and C require 10, 20, and 15 hours respectively. Find the total time required to fill the pool. Okay. So what they mean is first A and C work together, then B and C work together, then so on. The cycle repeats. Okay. So we need to find out how many hours it takes, how much time it takes. Okay. So we need to know that in the first hour A and C work together. Second hour B and C work together. Third hour A and C work together. Fourth hour B and C work together. So on. Okay. Let's not fill it now. We'll see how we need to see. We'll see rate of A and C is nothing but 1 by rate of A is 1 by 10 plus rate of C is nothing but 1 by 15. So this is 1 by 10 plus 1 by 15. 5 by 30, which is 1 by 6. Okay. We'll write it out of 60. Okay, just to because 60 is the number of seconds in a minute, right? Okay, R of B and C is 1 by 15 because that is C, and 1 by 20 that is B. Okay, so that is nothing but by 60 threes and fours and threes, so 7 by 60. Okay, now let's start tracking it after 1 hour. Okay, how much of the tank is filled is 10 by 60 because A and C work together. After 2 hours, it is 10 by 60 plus 7 by 60, which is 17 by 60 is filled. That is B and C working together at the end of 2 hours. In the second hour basically. So after that it is this part plus 10 by 60, right? So A and C are working together. That becomes 27 by 60 done. Okay. Then in the fourth hour, it is 27 by 60 plus 7 by 60 because B and C are working together, and this is 34 by 60. In the end, at the end of the fifth hour, 34 by 60 plus 10 by 60, which is 44 by 60. This is A and C working together. In the sixth hour, it is 44 by 60 plus 7 by 60. That is B and C working together. So this becomes 51 by 60. And in the seventh hour, okay, there is not one whole complete hour, because 51 by 60, it only needs a additional 9 by 60, okay. This does not take 1 hour, because A and C together can fill 10 by 60 in 1 hour, okay. So it takes almost 1 hour. So we need to find out how long this takes, okay. So we know in 1 hour 10 by 60th of the tank can be filled. So 9 by 60th of the tank can be filled in how many hours? Okay, how many minutes basically? So we cross multiply, we get 9 by 10 hours. Okay, so if you want to convert into minutes, you have to multiply by 60. So this goes 6 times and then you get 54 minutes. Okay, so the last cycle is only 54 minutes long, and you have 6 complete hours. Okay, so 6 complete hours and 54 minutes. So that is nothing but 6 hours and 54 minutes. That's the answer. So this goes on for 5 A and C, 6 B and C, and then there's 54 minutes, 6.54, and this is A and C. Okay, last question. Two pipes A and B are connected to drain out a water tank. A alone can drain it in 1 by 20 hours. B alone can drain it in again 1 by 20 liters per hour. Okay. Find the capacity of the water tank. Given that they are working together, they require 12 hours to completely drain out the tank. Okay. So cut. Okay. So basically, what we do in the beginning is we assume the capacity of the tank is X liters. Okay. X liters. So the rate of A will be nothing but 1 by 20. Okay, because it takes 20 hours to drain out the whole tank. Okay, and the whole tank we assumed it is X liters. Okay, so this is nothing but X by 20 liters per hour, right? So this is the rate of A, and rate of B is, we'll write it in liters per hour. So B is 20 liters per hour, so that is definitely only 20 liters per hour. Okay, and the rate of A is X by 20 liters per hour. Okay, working together they require 12 hours to completely drain out the tank. Okay, so if the whole see, if in 1 hour X by 20 of a liter, I mean X by 20 liters per hour is done by A, so in 12 hours it will be 12x by 20 liters by A, and then by B it will be 20 into 12 liters by B only. Okay, this is equal to X, because X liters are drained out. Okay, this is the tank capacity, and this is the number of hours. This is the number of hours. This is capacity of A. This is capacity of B. Fine. So now we get X is equal to 12x by 20, that is 3x by 5 plus 20 into 12. Okay, we'll leave it like that. So we take this side, we get 2x by 5 is equal to 20 into 12. So we can cancel this 10 times and this 5 goes that side. X is equal to 600 liters. So that's the capacity of the tank. By this we come to the end of this pipes and flow topic. Again, if you haven't watched the rate and work video, I highly recommend you to watch it, because it's very similar to this pipes, and I will see you in the next chapter. Thank you for watching.